Hello everybody, this is Mr. Tomlinson and this is the probability test unit 2 practice test. First question is, Simon brings the game Bamboozled to lunch. Inside there are 30 jelly beans, of which 15 are tasty and 15 are disgusting. The 5 friends sitting at the table take turns selecting and eating a jelly bean. What is the probability that the first friend gets a disgusting jelly bean? Well, there's 15 disgusting ones, 30 total, so it seems pretty obvious that the probability of a disgusting is equal to 15 out of 30. If the first friend gets a disgusting jelly bean, what is the probability that the second friend will get a disgusting jelly bean? Now remember, they're eating the jelly beans, so they are not replacing them. So the probability of disgusting number 2, the second one in a row, would be 14 out of 29. There would only be 14 disgusting jelly beans left and 29 overall jelly beans left. Now, are the first friend gets a disgusting jelly bean and second friend gets a disgusting jelly bean independent? The answer to that is no, they are not. No. Because one event affects the probability of another, or of the other. Number 2, a 6-sided die is weighted so that the numbers 1, 2, 3, 4, 5 are equally likely to occur. The number 6 has a probability of 0.5. So what that means is the other 5 sides have a probability of 0.5 total and have to be divided equally amongst themselves. So the probability of rolling an odd number, would be the probability of rolling a 1, a 3, or a 5. Well, the probability of rolling a 1, a 2, a 3, a 4, or a 5 is equal to 0.5 in an equal proportion, meaning each of these probabilities is 0.1, So the probability of rolling a 1, a 3, or a 5 will be 0.1 plus 0.1 plus 0.1. Now, each of these rolls is mutually exclusive of the other. I cannot roll a 1 and a 3 at the same time, or can I roll a 3 or a 5 at the same time? So we don't have to subtract anything. There's no and statement to subtract, so the probability is just 0.3. Next is we look at Ken and Jen wanting to have 3 children. The probability of having a boy is 50% on each birth. So that means the probability of having a girl is also 50%. So 0 boys would be 0.125 probability, 1 boy 0.375, and 3 boys 0.125. So what is the probability of they will have 2 boys and 1 girl, which is this probability? Well, if I take the sum of these 3 probabilities, I get this is 0.375 and 0.125 and 0.125, so this is 0.5 plus 0.125 or 0.625. So whatever's left over goes in here for 2 boys, so it's 1 minus 0.625, which is 0.375. We could also do this on a tree diagram, but I decided to show it to you here. If you look over here, there's all these possibilities. Well, boy only happens 1 out of 8 times. 1 out of 8 is 0.125. And then if you have 1 boy, you would go down here wherever there's 1 boy. 1, 2, 3. 3 out of 8 is 0.375. The same thing with 2 boys. 2, 2, 1, 2, 3. 3 out of 8, 0.375. It also works here. What is the probability that Ken and Jen will have at least 2 boys? Well, we take 0.375, which goes here, which is this probability, and I'm going to add that to 0.125. Remember, we can't have 2 boys and 3 boys at the same time. But if we're taking the probability of having 2 or more, we need to calculate probability of 2 boys plus the probability of 3 boys plus the probability of 3 boys, and that is going to be 0.5. But again, these numbers, 0.375, which is from A, plus 0.125, which is given right up here on the top at 3 boys. Okay, for number 4, Mr. Simonetti asked all of his students what month they were born. Then he classified them according to whether they were born in winter, spring, summer, or fall. He then gave his students the following clues, okay? The probability of not fall is equal to 0.8. The probability of summer or fall is equal to 0.58. And the probability of spring or summer is equal to 0.65. So let's start with the probability of not fall. Probability of not fall means the probability of fall is 1 minus the probability of fall complement, which is not fall. We'll write that as fall complement. Well, that means 1 minus 0.8 is 0.2, which will go here. So 0.2 goes in for fall. Then it says the probability of summer or fall is 0.58. So that means the probability of summer, because you can't be summer and fall at the same time. Okay, those are mutually exclusive events. So probability of summer or plus the probability of fall equals 0.58. Well, that makes summer 0.38 because I take 0.58 minus the 0.2, which is fall, and that makes this 0.38. And then it says the probability of spring or summer, probability of spring or summer is 0.65. So that means the probability of summer plus spring, probability of spring is equal to 0.65. So summer is 0.38, spring is 0.65, which makes the probability of spring, I believe it's 0.27. Okay, now we have everything else, so we just need to take 1 minus the sum of spring, summer, and fall to get winter. So I'll leave that to you and I'll put the answer up. You can pause the video and just finish it. So the sum of spring, summer, and fall was 0.85, which makes winter 15%, 0.15. What is the probability that a randomly selected student is born in the winter or the spring? Well, I just simply add winter and spring together. So probability of winter plus probability of spring, that has to equal 0.15 plus 0.27, which equals 0.42. What is the probability that a randomly selected student is not born in the spring? So not born in the spring is 1 minus the probability of spring. So not born in the spring is the probability of spring complement, which equals 1 minus the probability of spring. Okay, the probability of spring is 0.27, so we just plug in 0.27 and we get 0.73. Very good. Okay, Mr. Chauvet, I guess it is, recorded the number of times her students attended math tutoring session and whether or not the student was absent more or less than 5 times during the school year. The results are shown in this two-way table. Okay, so we got a nice two-way table here. So we're going to check it out and we're going to look at the problems here. Probability of 5 plus absences. So I'm going to go to absences here and I'm going to look at 5 plus absences. I'm going to look at the total number of 5 plus absences. That's 12 out of the total number of people is 75. So the probability of 5 plus absences is equal to 12 out of 75. Probability of 0 tutoring sessions. So the tutoring sessions are on the vertical here. They're across the top. And if I look at the 0 tutoring sessions and I go down here to the total of 0 tutoring sessions, okay, then I have 50, okay? So probability of 0 tutoring sessions is equal to 50 out of 75. Okay, so the probability of 5 absences or 10 tutoring sessions. 5 absences or 10 tutoring sessions. So I'm going to take 12 out of 75, which is, now, actually, I'll tell you what. Let me write this formula. Okay, so I'm going to take the probability of 5 plus absences plus the probability of 0 tutoring minus the probability of 5 plus absences and 0 tutoring. Remember, I have to subtract off the combination of the two because these two are not mutually exclusive events. So I've already got 12 out of 75 plus 50 out of 75. That is 5 plus absences plus 0 tutoring sessions. That's right here. I've got those two numbers. So this is 12 out of 75 plus 50 out of 75, and I'm going to subtract the probability of 5 plus absences and 0 tutoring sessions. 5 plus absences is here, 0 tutoring sessions is here. The intersection is 2 out of 75. So overall, this should be 12 out of 75 minus 50, or plus 50 out of 75 minus, this is 2 out of 75, because there's two that are an and statement, so that would be 60 out of 75 overall. Are they mutually exclusive? They are not mutually exclusive, these two events, because they can occur at the same time. There's two students who have, they are not mutually exclusive. No, they are not. They are not. Because both events can happen at the same time. Can happen at the same time. So that'll do it for this initial video. If you'd like to watch the rest of the solutions, just keep going on the playlist.